Welcome to Problem Solving through Programming. Today we are going to discuss about flowchart. So what is flowchart? Flowchart is a diagrammatic representation. It is a diagrammatic representation of the program or the problem to be done. Okay. So it illustrates the sequence of operation which is to be performed through diagrams. Okay. So it is going to illustrate sequence of operation which is to be performed. Which is in the diagrammatic form. Okay, so each step is represented by a different symbol, right? Each step represents or represented by different symbol. That is, each symbol contains short description of the process, and the symbols are linked by arrows. Symbols are linked by arrows, and your flowchart is easy to understand. Diagrams. And we have a clear documentation by doing the flowchart. And it helps, actually your flowchart helps to clarify or helps in clarifying the actual process. Okay, so flowchart is a graphical representation of steps, right? So it is actually easy. It is represented by different symbols, and all different symbol is linked by arrows, and it is easy to understand. It is having a clear documentation, and it easily clarifies the process to be done. Okay, and we have different symbols, as I said you, flowchart symbols. So if I use this shape, right, it is either start or stop, and if I use a rectangle, it is the process. So this is for termination or for the start, and this is for the process, and this is for your input and output, for feeding your input and output. I'm just giving you the basic symbol. Okay, this is for your rhombus, is for your decision making, and you will have arrows to connect different symbols, and the circle one is one page connector. If your flowchart is ending in one page and it is continuing, so you can give it by this connector, one page connector. Okay, so these are some of the basic flowchart symbols. Okay, next we'll see what are the guidelines for developing the flowchart. So we have to keep some points in mind while developing a flowchart. So every flowchart can have only one start and one stop. So the first point, flowcharts can have only one start and one stop symbol. Okay, so I said you that a small circle is a one page connector, right? So this one page connector are referred using numbers. Connectors are referred using numbers. For example, in one page it is ending, so I will end like 1, and then next it is continuing. Actually the flowchart is continuing, means again I have to give like 1 and I will continue like this. Okay, and also we have a connector called off page connector. It will be like this. Okay, so this off page connector are referred using alphabets. Okay, so like if I end like this with A, and I have to start with A like this, right? And the general flow is uh, top to bottom or left to right. Okay, and also arrow should not cross each other. Okay, and within the symbol, see, you have to write it very briefly within the symbol. Okay, so what is this? So the direction of the flow is only from top to bottom, right? Okay, fine. So now we'll just see one flowchart, example flowchart. So it should always have one start and one stop, right? So I start. Okay, inside the symbol we should write it very briefly. Start. Okay, let us see for that adding two numbers. So what is this symbol for? It is used to input and output. Okay, so here I will give like input number 1 and number 2, or read number 1 and number 2. So input number 1 and number 2. So the symbols are connected using the arrows. And what is this rectangle for? The rectangle is for processing. So what we have to do, we have to add two numbers and store it in some variable. So sum is equal to num1 plus num2. Okay, so after doing the calculation, what we have to do, we have to output, right? We have to print this sum. So for that also we have to use this symbol. Okay, so we can write like print sum. After that we have to end it. End. Okay, so this is called as flowchart. Right, suppose if we have any decision making, okay, in the program, so we'll have we'll have this numbers. So if I is greater than 10, yes means you do this process, no means you can do this process, something like that. Okay, otherwise you stop. Something like that we can do for a decision making. Okay. Next we'll discuss about pseudocode. What is pseudocode? Pseudocode is simply an implementation of algorithm in form of annotations and informative text written in plain English. Okay, I will just write the definition. So pseudocode is simply an implementation of an algorithm in the form of annotations and informative text written in plain English. See, actually pseudocode is it is not actual programming language. It is not actual programming language. It has no syntax like a programming language. Thus it can be compiled or interpreted by the computers. Okay, so it is actually a simple English syntax, right? So what is the need of this? What is the goal of writing your pseudocode? It is to provide high level description of an algorithm. So pseudocode provides high level description of algorithm. It is similar to programming code, but it is not a programming code. Okay, it will explain about the algorithm, and no specific for programming languages interpreted here. Pseudocode can be transferred into actual program code. That I will write. So your pseudocode can be transformed into actual program code. Okay, so pseudocode, it is similar to programming code. It is similar to programming code, but it is not a programming code. Okay, it actually explains about the algorithm. Explanation of algorithm, right? And your pseudocode can be transformed into actual program code. It is very simple English syntax. And now we'll see how to write a pseudocode. So how to write a pseudocode? So for writing that, we have to follow some guidelines. So first one is sequence of operation should be decided and arranged. Then only we should write the pseudocode. Okay. First, sequence of operation need to be decided and arranged. Then only we should write the pseudocode. Okay, and the second guidelines is start with the statement that establishes the aim of the program. Start with statement that establish the aim of the program. Okay. So let us see one example. So let us check whether the given number is odd or not. Okay. So example to check the given number is odd or even. So we'll just write a pseudo code for this. Yeah, could you just tell what is the advantage of writing this pseudo code? Advantage of pseudo code. So actually it improves the readability of any approach. Okay, it is one of the best approach to start implementing the algorithm, and it acts as a bridge between the program and the algorithm, or bridge between the program and the flowchart. Okay, also it works as a rough documentation, so the program of one developer can be understood easily when the pseudocode is written. So that is the main purpose. Okay, so it actually explains the main goal of pseudocode. It is to explain what exactly each line of program should do. Okay, so like for example, for checking this order even, so before this, one second, I'll tell you what should be done and what should not be done. Okay, so before this, okay, so the guidelines. So the first guidelines is sequence of operation should be decided and arranged. Only then we should start writing the pseudocode. And the start with statement that establishes the aim of the program. And the next is intended of the statement. Okay, you should have indentation between the statement. Intend the statement. Why we need to have this indentation is only then it will help to understand the execution mechanism of any decision control. Suppose if we have decision control, if we have indentation, then it will be easy to understand the mechanism. Okay, so that is the purpose of having indentation. So indentation means, for example, if yes, in the what decision control, if yes, then print response like I am in. If no, print response like I am not. Just for an example. So you can see here, it is starting here, then it is here, it is having the indentation. Okay, so this indentation of statement helps to understand the execution mechanism of any decision control. So it will be easy for reading. Okay. The fourth guidelines is use proper naming convention. Okay. And the fifth guidelines is we have to use suitable sentence. Okay. use suitable sentence casting. Like uppercase, constant, lowercase, variable, something like that. And the sixth one is, don't be abstract with the pseudocode. Make the pseudocode elaborate and explanatory. Okay, you should not confine your pseudocode. Don't abstract the pseudocode. Okay, make it elaborate. And we can use structured programmings. Like if, else, for, while, case. So these are. And then make your pseudocode to be very clear, very finite, comprehend and understandable. Okay, so you should make your pseudocode to be very clear, finite and comprehend. It should be understandable. Even for the layman or for the client, your pseudocode should be understandable. Don't make too much of technical terms. Okay, so these are the guidelines for your pseudocode. Okay, so what are the do's and don'ts of your pseudocode? Do's and don'ts. So we can use control structure. So we have to use control structure. We have to use appropriate naming conversion. Indentation. So it is very much important. It should be simple. It should be very concise and understandable. That is, it should be precise. So these are your do's. And what are the don'ts? Don't be too generalized. Okay, so don't be too generalized. So don't make the pseudocode as abstract. You explain clearly. Okay, don't abstract the pseudocode. Okay, these are the do's and don'ts. So now can you guess what are the advantage and disadvantage of your pseudocode? So advantage of pseudocode, it can be easily converted into programming language. It is easy to understand even for the layman, or we can say it is easy to understand for a non-programmer also. And here your syntax errors are not important, right? It implements this structured concept. We don't have any special symbol. We don't have any specific platform for writing this. Okay, we can even just write it in Word, MS Word. Right, so these are all the advantages. What are the disadvantage? We don't have any standard for this. No standard is followed, and compilation and execution of the program cannot be done with this pseudocode, and it is also time consuming. Okay, so you know the advantages. So advantage, it can be easily converted to program, and it is easily understandable for even non-programmers. And syntax error is not important here. important, and it is having a, it implements this structured concept. We don't have any special symbol, and also there is no specific platform for this. So we can just use Word. And what are the disadvantage? So we don't have any standard here, no standard is followed, and compilation and execution cannot be done. And it is very time consuming to produce the result. Alright, understood? So now we'll just go for an example of writing pseudo number. So we'll take the same number, adding two numbers. For this we'll write a pseudo code. So first step, we'll start program. Second, enter two numbers, say A and B. Third, add numbers together. Fourth, print the sum. Fifth, end the program. Got it? Right? We'll see one more example of that. Let us say compute the area of rectangle. Area of a rectangle. So let us write pseudocode for this. So first, what we have to do for computing area of rectangle, so we need to know what is the length and what is the width. Then area can be calculated as length into width, right? So first, what you have to write? Start the program. Second, get the length L and width W. And third, what is that? We have to compute the area, right? Compute area equal to length into width. And fourth, display the area. And fifth, end program. Right? We'll see one more example. Let us take one decision making algorithm or pseudocode. To input the examination mark and its grade, input examination marks and award grade. Okay, so what we have to do? So you have to use variables which is of type integers, right? So that all we have to do. I'll just write only the condition part. Okay. So if mark greater than or equal to 80, display, I can write it in caps. Okay, 80, display as distinction. If here I am writing only the control statement part, okay, decision making part, is equal to 60 and mark less than 80. Okay, so then we have to display like first class. If mark is greater than 50 and less than 60, display second class. If mark is less than 50, display fail. Right, then you can end the record. Got it? So this is how we write your pseudocode.